Is the board visible to you?
No.
No, wait a minute. Let me share the screen with you. Yeah, is it visible to you now?
Yeah.
All right. So let's discuss about current electricity, which we are going to discuss
Yeah.
now. Okay. So that's the start. So ICSE class 10th physics, and the chapter is electric current. Okay.
Okay.
So this is ICSE class 10th. All right. And the chapter which we are going to discuss is current electricity. Very important chapter. Current electricity. Clear? Now
Yeah.
let's discuss about current electricity first. Okay. Before discussing current electricity, let me tell you that we need to first discuss about matter. We need to first discuss about the charges, what are called as the charges. We need to discuss about the law of conservation of charge. Then we will be moving towards the current electricity. Okay, because this is all the base. Clear? Now, so to discuss about current electricity, we need to first discuss about very important heading, which is matter. We need to first discuss about matter. Now can you tell me what matter actually is?
It is what everything is made up of.
Yeah, so
It is
you
the
can actually define it like anything which has some mass and which occupies some space, that is called as matter,
Yeah.
and that can be felt by any of our five senses, that is called as the matter. Very important. So you can write that
Yeah.
anything that has some mass and occupies some space and can be felt by any of our five senses is called as matter. Clear?
Yeah.
For example, let me give you one example for matter. For example, the book which you are seeing, the laptop which you are seeing right now. Okay, book, table, chair, air, etc. What are all these? These are matter. Clear? The book basically it is occupying some space, it is having some mass, right? That's the reason why it is called as matter. Table, you are sitting on the table, there is some space which is being occupied by the table. Table has some mass, you can feel the table through your five senses, right? Through your skin you can have the sensation that you are sitting on the table. Then chair, air is also a matter, although you are not able to see it, but still it has some mass, it is occupying the space in our atmosphere, right? That's the reason why it is called as matter. In a similar way, there are some things which are not a matter, they are not counted in a matter. Can you give me the names of those things which are not counted in matter? Tell me.
Feelings.
Very good. Feelings like love, hatred, arrogance, ego,
Yeah.
affection, and all of that, anger.
Yeah.
So these things, these are not counted in matter. Clear? What is called as the matter? Now, so as we have discussed about matter, now let us move ahead and let's discuss about very important entity which is called as the atom. Atom. So everything is made up of matter, right? Everything is made up of matter, and matter, it is composed of atoms. Now what are atoms actually? So atoms, these are the smallest individual unit from which the matter is made up of. Clear?
Yeah.
So if someone asks you to define it, so the smallest individual unit from which the matter is made up of. Clear? So everything, every matter, it is made up of atom. It is composed of atoms. For example, you have a book right here. Okay, like for example, you have a book right here with you. Okay, and
Yeah.
obviously this will be made up of matter, small particles, atoms.
Yeah.
This is all a matter, and matter is composed of atoms. Small particles are there, right?
Yeah.
So this is what? These are atoms. Now there were several theories that came from time to time explaining about the structure of atom. Clear? Several theories came.
Yeah.
Several theories came to explain the structure of atom. Clear?
Yeah.
Very good. So now what were those theories? The very first theory that we are discussing is Dalton's atomic theory. Which one? Dalton's atomic theory. Now, since that delta, all these structure of atom is not in your course, because we will be directly discussing the current electricity, so you don't need to write all of this. I'm just explaining you in simple words, okay? Because this is not the part of the syllabus in physics, okay? So now, number first is the Dalton's atomic theory. So according to Dalton's atomic theory, it was believed that atom cannot be divided. Okay, atom is the smallest individual unit. Okay, and it cannot be divided. It cannot further be divided. It is the smallest. Clear?
Yeah.
According to Dalton's atomic theory. However, this theory was failed. Okay, later electrons, the subatomic particles or the fundamental particles were discovered. Okay, which were what? They were electrons, protons and neutrons. Okay, it failed. Why it failed? Because nucleus was discovered by Rutherford. Okay, electrons, protons and neutrons were discovered. Electron was discovered by J.J. Thomson. Okay, proton was discovered by Goldstein. Clear? So fundamental particles like electrons, protons and neutrons were discovered. Particles were discovered. Clear?
Clear.
And these fundamental particles, okay, what are these by the way? These are electrons, protons and neutrons. Electrons, protons and neutrons. Now when these fundamental particles were discovered, several structure of atom came. Okay, several structure came, like that one model was the watermelon model of an atom or Thomson's model of an atom. It came. Okay, then after that Rutherford model of an atom came. Clear? So different models from time to time came explaining about the structure of the atom. Clear? Now these electrons and protons, these are by the way called as the charges. If I look at the structure of atom, it looks like this. In a center there is a nucleus. Okay, and near the nucleus there is an extranuclear portion, right?
Yeah.
There is an extranuclear portion. There is a space in which the electrons revolve. Okay.
Okay.
Clear? Now So this is actually the nucleus, and this nucleus, it consists of the main mass of the atom. Okay, it consists of the protons and the neutrons. Protons and the neutrons. The main mass of the atom is because of this nucleus, whereas in this extranuclear portion there are the electrons which are revolving. I am not going to go deep inside this, okay,
Okay.
because we will be discussing only about the electric current. When I will be getting the time, some extra time to explain, I will explain the structure of atom in more detail. Okay.
We've already discussed it in chemistry.
Yeah, we have this in chemistry as well. So we will be discussing it there. So this is extranuclear portion, and there electron revolves, right?
Yeah.
So here electron will be revolving. Okay, and these are the fixed energy shells. Okay, fixed energy shells, these are like this.
1 second.
Okay, so you don't need to draw this all. Okay, we have all of this. Okay, don't need to draw this. Now that was just for you for explaining. Now we have very important thing, which is charge. So we discussed about the fundamental particles, right? Now
Yeah.
we will be discussing about the charges. Since fundamental particles are clear to you, let's discuss about the charges. So charges, this is the property of a matter. Okay, and in the fundamental particles there were two kind of charges. Although there were three, one was with no charge, which was neutron, but since it has no charge, we are not going to count it inside the charge. Clear? So there are two kinds of charges. Number one is the positive charge, which is possessed by whom? Tell me. Positive charge, which is possessed by whom?
Proton.
Proton. Very good. And then there is a negative charge, which is possessed by
Electron.
which is possessed by electron. Clear. Very good. Okay, so positive charge, it is possessed by the proton, and negative charge it is possessed by the electron. Clear? Now, so these are the charges which we have discussed so far. Okay, now when we are talking about the charges, there are some of the points which we have to consider. Okay, so number one is the Coulomb's law. Okay, let's discuss about the Coulomb's law. Coulomb's law. Now what is a Coulomb's law? In the previous class, like in 9th class, you may have studied about the gravitational force, right?
Yeah.
Okay, so what was universal law of gravitation? Coulomb's law is very much similar to universal law of gravitation, very much similar. Okay, the difference is only of the charge and mass. Let me explain you. Suppose there are the two charges, this is q and this is minus q. Clear? These are the two charges which are separated by the some distance. This is plus q and this is minus q. So these are the two charges. Okay, and these are separated by some distance. Let us say the distance between them is r. Okay, now obviously this plus q will be attracting this minus q with some force F1. Okay,
Yeah.
with some force, and in a similar way this minus q will be attracting this plus q with some force. Okay,
Yeah.
so what will be the total force between these? It will be the total force, or we also call it as the Coulombian force. Okay, there will be the force of attraction between them. Clear? So the force acting between the two charges is directly proportional. So the force which will be acting between these two charges, it will be directly proportional to the product of the two charges, q and minus q. Clear? Product of the two charges, whereas it is inversely proportional to the square of the distance between these two charges, 1 upon r square. Okay, I will explain you what do I mean by this. Now you will combine both of these, so we will have this result, Q into minus Q upon R square. Or in simply you can like take Q1 and Q2 as well. Okay, let me take as Q1 and Q2. Would be better to take Q1 and Q2. Okay, let us take Q1
Okay.
and Q2. This would be much easier. So these are separated by the distance r. So according to Coulomb's law, the force acting between these two charges will be directly proportional to the product of the two charges, Q1 and Q2. Because both of these are positive, so these will be repulsive in nature, right? They will be repelling each other, not attracting, repelling. And this is equation number first, and it is inversely proportional to the square of the distance between them. So this is equation number second. So when you will combine both of these equations, you will get F is directly proportional to Q1 Q2 upon R square, and just remove the sign of proportionality. You will have F equals to K Q1 Q2 upon R square, where K is a constant of proportionality. Clear?
Yeah.
K is a constant of proportionality. Now, inversely proportional to R square means like whenever the distance will increase, the force is going to decrease. Clear? And this is evident actually. When the distance between the two charges will obviously increase, the force is going to decrease, and when the charges will be closer, they will be repelling or attracting each other. They will be putting a force on each other with a larger magnitude, right? So this is Coulomb's law. Understood what Coulomb's law is? Clear? So I am writing the statement here. Just copy down the statement. Okay?
What is K
Where?
in the last equation?
Okay. Let me first type the statement. Then I will, slide back. Okay?
Okay.
Are you able to see?
Yeah.
Yeah. So basically, what is Coulomb's law? According to the Coulomb's law, the force acting between the two charges is directly proportional to the product of the two charges, whereas it is inversely proportional to the square of the distance between them. Clear? This is the statement for the Coulomb's law. Okay?
Okay.
And what will be the formula? Maybe you were writing the formula. Formula is that is,
Yeah.
if Q1 and Q2 are the two charges separated by the distance r, then F is equals to K Q1 Q2 upon R square. Clear?
Yeah.
What I am trying to say?
Yeah.
Yes. So F equals to K Q1 Q2 upon R square. This is the Coulomb's law which we have.
What? Yeah. So what is okay? What's K?
K is basically the constant of proportionality. Okay, in the higher class, in 12th class, the value is also given, which is 9 into 10 to the power 9 Newton meter square per Coulomb. Okay, in your class the value is not given. That's the reason why I have just simply write it as K. Okay, that's the constant. For example, in the previous class you may have studied about the gravitational constant, capital G. The value is fixed, 6.67 into 10 to the power minus 11, right?
Yeah.
This was the value, Newton meters. Okay,
Yeah.
6.67 into 10 to the power minus 11 Newton meter square per Coulomb square. Not Coulomb, sorry. Newton meter square per kilogram square, right?
Yeah.
Like this. In a similar way, that this was for the capital G. In a similar way, this one which I am talking about, okay, F equals to K Q1 Q2 upon R square. K has also the value. What is the value of K? K equals to 9 into 10 to the power 9 Newton meter square per Coulomb. Per Coulomb square. Clear?
Yeah.
Newton meter square per Coulomb square. This is for the value of K. Okay, K is actually fixed. Okay.
Yeah.
Yeah. So it's a constant. You can say that K is what? K is a constant. In the higher class, K is 1 upon 4 pi epsilon naught. You will study all of this in 12th grade. Okay, so don't need to focus on all of this. They are just going to ask you simply what is actually this constant. Okay, what is the Coulomb's law. They are not going to ask you the numerical based upon this. Okay, they are not going to ask you. Simple. They are just going to ask you what is Coulomb's law. That's it, not more than that. Clear?
Yeah.
I hope it is clear to you. Now shall we move on?
Yeah.
Now, what was the relationship between the gravitational force and the Coulomb's law? Universal law of gravitation and Coulomb's law. So let us write here a relationship between universal law of gravitation, universal law of gravitation and Coulomb's law. What is the relationship? Let us discuss about that. So, in the previous class, when you discussed about the universal law of gravitation, what was universal law of gravitation? Suppose instead of the charges, there were masses. Suppose this is big mass, capital M, right? And this is small mass, small m. Okay? And these were separated by the distance, small r. Clear? So what was the universal law of gravitation? The force acting between the two masses was directly proportional to the product of the two masses and inversely proportional to the square of the distance between them, and the formula which we got was this: G capital M into small m upon r square. Wasn't this the formula which we got? Right?
Yeah.
For the universe, this was for the universal law of gravitation. I'm writing here, this is the formula for between the two masses, the force acting between the two masses, okay, in the universal law of gravitation. So this is universal law of gravitation. Clear? Now when I am talking about the Coulomb's law, okay, so what is Coulomb's law? There were two charges. Let us say this is q and this is a small q. Okay, you can also take q1 and q2, it doesn't matter, and these are also separated by the small distance small r, right?
Yeah.
So there will also be the force acting between them, which is called as the Coulombian force. Okay, and the Coulomb force acting between these will be given by how? Can you tell me what is the formula? F equals to
F is equal to K.
Very good.
Q.
Q into small q upon r square.
Yeah. Divided by r square.
Yes. Now, so basically both of these look similar. Yes, only there is a difference between mass and the charges. Okay, universal law of gravitation, the force is acting between the two masses, whereas in the Coulomb's law, the force is acting between the two charges. But everything is same, right? Almost. See? Okay. Basically, it is also following the inverse square law, isn't it?
Yeah.
Right?
Yeah.
Yes. Any more similarity that you can see?
The constant.
No, constant is not same. Okay, tell me the differences. Like, what are the differences there?
The mass and the Coulomb and the constants.
Okay, let me tell you one more thing. Okay, very important point. Just look here. See, let's take about the differences first. Okay, when I'm talking about the differences are visible in front of you. You just need to look at that properly. Okay, so what are the differences? See, m and m. Okay, so this universal law of gravitation, it can act between the sun and the earth, it can act between the moon and the earth, it can act between the sun and the moon, it can act between different planets. Okay, it is long ranging, right? Long ranging forces, isn't it?
Yeah.
They are the long ranging forces. They act at a very long range. Gravitational force is also acting between you and me, between you and your laptop, between sun and the moon, between sun and the earth, between moon and the earth, between Jupiter and the earth, right?
Yeah.
Gravitational force is there, so it's a long range force. Whereas if you look only at this force, this Coulomb's law here, what you are going to find, it's not a long range force, it's a short range force, right? Once the charges are separated by a very large distance, the force is not going to act between them. The force will become zero.
Okay.
Understood or not?
Understood.
Yes. So we can write that. I'm writing here what is the dissimilarity. Okay. What are the differences between them? Number first. Very important point. Okay. Let me write here. Okay. So universal or gravitational force is a long ranging force. Clear?
Yeah.
It's a long ranging force. Whereas Coulomb's force, or we can also say electrostatic force. Okay, it is also called as the electrostatic force because it is the force acting between the two charges. So electrostatic force acts at is a short range force. You can write is a short range force. Clear?
Yeah.
Now, important point. Second point. So can you see the second difference here? See, if you look here, m and m. Okay. So universal law of gravitation, it is always attractive force. Whereas if I will take, suppose I have plus q here, but if instead of plus q I take minus q here, so this will become attractive. Earlier it was repulsive. Now it will become attractive because there is minus q here. Different charges, like charges repel each other, whereas unlike charges attract each other. Okay.
Yeah.
So it depends upon the type of charges which you have. So to have the attractive force or the repulsive force, which means that electrostatic force can be repulsive or attractive, whereas the gravitational force is always attractive. Clear? Okay. So I am writing here. Gravitational force is always attractive, whereas electrostatic force can be attractive as well as repulsive. Depending upon the types of charges in consideration. Clear?
Yeah.
Any problem so far?
No.
Now Any more difference that you can see between these?
I don't know.
Electrostatic force is very much stronger than gravitational force, right?
Uh,
Okay.
mhm.
So number third point is electrostatic force, I'm writing here, is stronger, very much stronger than gravitational force. Clear about this?
Yeah.
Any problem?
Yeah.
Yeah, you have a problem.
No. There are
Okay.
no problem.
Okay. Now, what are the similarities? Let's talk about the similarities. Let's talk about the similarities between both. Okay. Between both the forces. What are the similarities? If I talk about the similarities, these were the differences which we just saw. Okay. Now, let me talk you about the similarities. So can you tell me what are the similarities?
The distance between the mass or
Very good.
Coulomb.
So they both follow the inverse square law. Both are inversely proportional to 1 upon r square, right? See, if you look here, this is also inversely proportional to 1 upon r square. Look here.
Mm-hmm.
And this is also inversely proportional to 1 upon r square. Okay.
Yeah.
So both are inversely proportional to r square. Okay. F inversely proportional to r square. Both are inversely proportional, isn't it? So both follow inverse
Yeah.
square law. Can I write this? Number one,
Yeah.
both follow inverse square law. Inverse square law. Clear? What I'm trying to say here?
Yeah.
So this is the point number one. Number 2 point. Okay, can you guess? Well, what's number 2? Both these forces operate in vacuum. Okay, both these forces operate in vacuum. Clear?
Mm-hmm.
Number third point. Number third point is these are conservative forces. What do I mean by conservative forces? They does not depend upon any path. Okay, they does not depend upon any path. I will tell you more about the conservative forces when we will be discussing about the work, energy and power chapter. Okay, there will be numericals based upon this concept. Okay, so these are called as the conservative forces. Clear?
Yeah.
Okay, so these are some of the similarities which is there in front of you. So you can note all of this, okay, or take the screenshot of this, and then after that we will move. Okay,
Yeah. Yeah.
all right. So we have covered the Coulomb's law.
Yeah. I'm done taking that.
Okay, you are done
Yeah.
now. Very good, then that's a great thing. So now we will be discussing about the new concept. So we discussed about the charge. Okay, now let's discuss about the SI unit of charge and the quantization of charge. Clear?
Mm-hmm.
Our next heading, SI unit of charge. Now remember, always remember that the SI unit of charge is basically what? It's Coulomb. What? It's Coulomb. Clear? SI unit of charge is what? It's Coulomb, which is denoted by capital C. Clear?
Yeah.
It is denoted by capital C. This is the SI unit of charge. If someone asks you what is SI unit of charge, you will say that Coulomb is the SI unit of charge. Okay?
Yeah.
Very good. Now let's talk about the quantization of electric charge. But before that, we will be discussing about the conservation of electric charge, or law of conservation of charge. Law of conservation of charge. So can you explain me what is a law of conservation of charge?
I don't know what it is.
Do you know law of conservation of energy? In the previous class you may have studied about law of conservation of energy.
I'm not sure. I forgot.
Okay. So basically, according to law of conservation of energy, you may have heard that energy can neither be created nor be destroyed. Okay, but can be transformed from one form to another form. For example, when you switch off the light, okay, switch on the light, what happens? The electrical energy gets converted into light energy. Energy is same, but it is being transformed. Clear? Energy is same. The whole energy, energy of the universe, remains constant. Okay, according to the third law of thermodynamics, it is constant. Okay, it never changes. It only transforms from one form to another form. Okay, that's it. In a similar way, there is a law of conservation of charge. According to law of conservation of charge, charge can neither be created nor be destroyed. The total amount of a charge remains constant in an isolated system. Okay?
Yeah.
Net charge always remains the same. You cannot create it, you cannot destroy it. It always remains the same. Clear? That is called as the conservation of electric charge. Law of conservation of charge. So what is law of conservation of charge? I am writing here. Okay? So just very important statement. According to law of conservation of charge, charge can neither be created nor be destroyed. However, it can only be transferred from one object to another object. Or we can also say, another definition is there, the total amount of charge in an isolated system remains constant. Clear?
Yeah.
So from one system, one object to another object, it can be transferred. For example, have you ever tried an experiment like when you were a child, that you just teared some paper, so you just got some pieces of paper and rubbed the scale with your head and then tried to attract those bits of paper? Have you ever tried that experiment?
Yeah.
Okay, there is a transfer of charge there. Okay, clear? There is a transfer of charge there. This is called as the concept of static electricity. What?
Yeah.
This is called as the static electricity. We actually are studying current electricity. Static electricity you will be studying in a more detail in 12th class. Okay, but I am telling you actually that there is also a concept of static electricity. Okay, and law of conservation of charge it gets followed there as well. Okay, the total amount of charge always remains constant. You cannot actually create the charge, you cannot destroy the charge. Clear?
Yeah.
Yes. Okay, so this is how it happens. I hope it is clear to you.
Yeah.
Now So SI, we have discussed about the SI unit of charge, we have discussed about law of conservation of charge. Now let's talk about the quantization of electric charge. These comes under the properties of the charges, or you can also say characteristic of the charge. If someone asks you what are the characteristic of the charge, tell them that charge always remains conserved. Okay, it can neither be created nor be destroyed. Next is the quantization of electric charge. Electric charge is quantized. What do I mean by this? Quantization of electric charge, I am writing here, quantization of electric charge. What do I mean by quantization of electric charge? Okay, very easy. Quantization of electric charge. Quantization of electric charge means that, you know, that the charge, okay, it cannot be divided indefinitely. Okay, it is quantized. Clear? It is quantized. That is called as the quantization of electric charge. Okay. For example, the charge which you will be finding will always be in the magnitude of Ne. Q equals to Ne. Okay. So this is the charge Q. So it will have the magnitude of Ne. Ne is the electric charge. Okay. Now what is Ne? The value of N, it is always going to be 1, 2, 3, 4, 5 and -1, -2, -3 like this. Okay, 6, 7 like this. So N is always going to be the, you know, 1, 2, 3, 4, 5 like this. Clear? It is not going to be like this, 1 by 2, 5 by 4 like this. It's not going to be like this. Clear? Not in a fraction. Okay, or not in a decimal. Clear? So we can say quantization of electric charge means that electric charge cannot be divided indefinitely. Electric charge cannot be divided indefinitely. Okay, and just remember this important formula, Q equals to Ne, because based upon this we will be solving many of the numericals as well upon the current electricity. Okay, that's the reason why teaching you this concept about the charge was really very necessary. Okay,
Okay.
understood?
Yeah.
All right, so now let's move ahead. Now, as we have discussed this, let's talk about the electricity now. So we have discussed about the quantization of charges. Clear?
Yeah.
Let me write the statement for the quantization of the charge as well. Okay, I am writing here. According to the quantization of charge, any charge particle can have a charge equal to some integral number, number of E, or I can say that is Q equals to Ne. Okay, where the value of N will be how much? N equals to 1, 2, 3, 4, 5 and so on. Clear? Like this. And what is E? E is the charge on the electron. Clear?
Yeah.
So now quantization of charge is clear to you. Now let's talk about the electricity. So we have two kinds of electricity.
Yeah.
So let's talk about electricity. And number one is the static electricity. Okay. Number one is the static electricity. And another one is the current electricity. Clear? Static and current. Now, what's the difference between these two electricity we will be discussing here? Okay, static electricity is not going to take a lot of time because it is not there in the course, so I'm not going to explain it. But we will be discussing about the current electricity. Now, what is static electricity? Static means the charges from the static. The word is static. Static means at rest. Okay. So here what will happen? In this static electricity, there will only be the transfer of the charges from one system to another system. Okay. The charges will remain at rest and there will only be the transfer of the charges. Clear?
Yeah.
Only transfer of charges will take place. Transfer of charges will take place from one system to another system. One system to another system. Clear?
Yeah.
The charges, they actually don't move. This is the reason why it is called as static electricity. Whereas in current electricity, when we are dealing with current electricity, there is the movement of the charges. Okay, and due to this movement of the charges, there is the current. Okay, the movement of charges, electrons and protons are there. Okay, charges, that is electrons and protons are there. Clear?
Yeah.
This is current electricity. We will be discussing more about this static and current electricity. So static electricity, I have already given you the example. Okay, how does this happen? Now, for example, one example of static electricity is that when you rub the balloon with your hair, okay, and then when you try to, stick that with the wall, it gets stick. Yeah, yes, because of the friction. Okay, static electricity also called as the charge due to friction. Okay, frictional electricity as well. And another one is the current electricity. In this current electricity, there will be the movement of the electrons and the protons. How does this happen? Let us discuss about that. So now when someone asks you, so we discussed about the charges, right?
Yeah.
Now let's talk about the current electricity in a great detail. Current electricity. Now when I am talking about current electricity is that amount of charges, okay, flowing across a conductor in a unit time, that is called as what? Current electricity. Okay, for example, that is called as the electric current. For example, suppose this is a conductor. Always remember that the current is going to flow inside the conductor or a semiconductor, not the insulator. Okay. So now we have this wire, suppose, and this wire is actually connected to a battery. I will tell you the concept of potential difference as well, don't worry.
Okay.
Okay, just for now imagine that this is connected to a battery. Okay, now What are these? This is a conductor, this is a battery. Now when you will switch on, okay, the current, when you will basically switch on this battery, when you will be having the potential difference applied across the ends of the conductor, what will happen? The electrons will start to flow. Suppose the electrons are flowing in this direction, okay,
Yeah.
in this direction they are flowing, okay. Now what will happen? In this direction electrons are flowing, current is going to come in this opposite direction. Always remember that current, it starts from the positive terminal of the battery and ends in the negative terminal of the battery. Clear? And
Yeah.
whatever is the direction of motion of the electrons, suppose electrons are moving in this direction, electrons are moving in this direction, so the direction of the current will be opposite to the direction of the electrons. So the direction of the current will be in this direction, which means opposite to the direction of electrons, okay,
Yeah.
opposite to the flow of electrons, and this is called as the conventional direction of current, also called as the conventional direction of current. Clear? So if in whatever the direction electrons are flowing, the current will be opposite to the flow of the electrons, whereas it will be in the same direction to the flow of the protons. If the protons are flowing in the left direction, then current will also be flowing in the left direction. So it is in the same direction to the flow of the protons, whereas to the flow of the electrons it is always opposite. Clear?
Yeah.
So this is how we will be defining the current. So now what is current? If someone asks you what is current, it is denoted by the symbol capital I, okay. It is the rate of flow of charge across a conductor, okay, Q upon T. What is Q? Q is the charge, total charge, okay. Q is the charge. So the rate of flow of charge, across a conductor is called as current. Clear?
Yeah.
Okay, so how much of the electrons or how much of the protons, or you can say in short how much of the charge, okay, is flowing across a conductor in a given time, that is called as the current. Clear?
Yeah.
That is called as the current. Now what will be the SI unit of current? Let us discuss that as well. SI unit of current. SI unit of current. Remember, SI unit of current is, see, let us say Q is 1 coulomb. Let Q is, so this we are taking this Q, the unit of Q, SI unit of Q is what? Tell me.
Coulomb.
Coulomb. So let Q equals to 1 coulomb and time is, what is the SI unit of time? It is seconds. Okay, so coulomb and second. T equals to 1 second. Therefore, SI unit of current is coulomb per second. Okay,
Per second.
and this coulomb per second, it is called as the ampere. Okay, so 1 ampere.
Yeah.
1 ampere. So ampere, it is denoted by the symbol capital A. Okay, so I am writing here 1 ampere, 1A, okay, equals to 1 coulomb per second. Clear?
Yeah.
1 ampere. So SI unit of current is what?
Coulomb per second.
Yes, SI unit of current is ampere or coulomb per second. Current is ampere, also called as coulomb per second. Clear?
Yeah.
Any problem so far?
No.
Okay. Now, if someone asks you define 1 ampere, okay? If someone asks you define 1 ampere, how you are going to define it? Can you tell me? Tell me how you are going to define it. Try to do that. Okay, 1 ampere is 1 coulomb per second. What is current? Current is the amount of charge flowing through a conductor in a given time. Okay.
Mm-hmm.
Tell me.
The the Coulomb. I don't know how to explain.
Okay, wait a minute. So define 1 ampere. So this is a conductor, suppose. Okay. So what was current? Current was the total charge which was passing through the conductor in a given time, right? What is 1 ampere? 1 ampere means that 1 ampere means 1 coulomb per second. 1 coulomb upon 1 second, which means 1 coulomb per second. Okay. So we can actually define this 1 ampere as the current in a conductor is said to be 1 ampere. I am writing here when 1 coulomb of charge flows through it in 1 second. Clear?
Okay.
Okay. So the current, I am writing here, very easy definition. You just have to make the definition by yourself. Very easy. The current in a conductor is said to be 1 ampere, or you can say 1A, when 1 coulomb of charge flows through it, through the conductor in 1 second. Clear?
Yeah.
Any problem?
No.
Clear about this?
Yeah.
Okay, so this is the 1 ampere current. This is how you are going to define 1 ampere. I hope everything is clear to you, and this is it for today. In the next class we will be discussing more about the electric current. We will be discussing about the concept of the potential difference. We will be discussing about resistance. We will be discussing about resistivity and all of that. Okay.
Okay.
All right then.
Thank you.
So we will be meeting in